Hello, my name is Zeynep Su Yüzbaşıoğlu and I'm a second-year molecular biology and genetics student at Bilkent University. And this is my Physics 102 lab project video. So in my lab project, I calculated the resistivity of a wire by increasing the length of the wire within the circuit. I also wanted to see how the resistance changes within the circuit if I increase the length of the wire in the circuit. And I used three formulas in total. The first one is the Ohm's law, which is voltage equals to current times resistance. The voltage is measured in volts, the current is measured in amperes, and the resistance is measured in ohms. And I singled out the resistance in one side, so it is resistance equals to voltage over current now. And then the other formula I used is the area of a circle, which is pi times r squared, and r is in meters for my calculations. And then the last formula I used is the resistivity formula. It is resistance equals to resistivity over area times length. So in order to make my calculations easier, I took this value as a linear equation where the y values are the resistance and the length is the x values and the gradient is resistivity over area. So I will find the gradient and then I'll multiply it by the area to find the resistivity value. I will find the gradient with the help of a graph, and in the experiment I took the wire, I attached the power source in one side of the wire, and on the other side of the wire I attached the multimeter, and then I attached the multimeter back to the power source, and that is now in series with my wire, and it will measure the current. And then I took another multimeter and then I measured it in parallel with my wire, and it measures the voltage. My experimental setup can be seen in the next video, and I made my power source 20 volts so that I can measure the voltage and the current. I changed the length from 20 centimeters till 70 centimeters with the use of a ruler, and then I found my experimental resistivity as 5.25 times 10 to the minus 7, but the actual value is 4.9 times 10 to the minus 7, so I have a 7.14% error. 7.14 is actually a low error rate, however it is still an error rate, and I believe the main contributor for the error is the inaccuracies within measuring the length, because my ruler was not 100% accurate and I wasn't able to see the millimeters very efficiently. And I used crocodile clamps, which changed the length values by approximately 0.5 centimeters. And another problem could be due to the multimeters that I used. The multimeter errors could be due to charge buildup, and they're kind of old, and also the equipment has errors within them. Another main contributor to the error rate could be the connectivity problems with the wires and the circuit. From the values, it can be seen that the resistance increases with increasing length. And that is all. Thank you.